Let's go ahead and run through some transformations. One big picture idea that I want you to keep in mind is you're always looking, is the symbol inside or outside of grouping symbols? If it is outside of grouping symbols, it's going to affect something vertically. In other words, the height, shifting it up or down, or reflecting across the x-axis. And if what's happening is inside of grouping symbols, that's going to affect something horizontally. So the width, or moving something right or left, or reflecting across the y-axis. And then finally, before we move on, if it is inside of grouping symbols, you'll understand what I mean in a moment, but it's gonna act a little crazy, kind of counterintuitive. When something you think should go up, it's gonna go down. So inside grouping symbols, a little wonky. If you multiply a function by a -1, the negative is going to be located outside of grouping symbols. And so it's going to reflect across the x-axis. So here's my parabola, my original parent function, reflected across. Okay, now if the negative is inside of grouping symbols, we've replaced the x with -x, and it's going to reflect the graph across the y-axis. But if I take a point on this graph and I mirror it across the y-axis, it lands back on it. So when I reflect across the y-axis, the result, it's going to end up looking the same when it comes to a parabola. Okay, next one. Here we're going to look at multiplication. So when the multiplication is occurring outside of grouping symbols, it's going to affect the height. So how far it is away from the x-axis. Whereas when the multiplication is happening inside of grouping symbols, it's going to affect the width. Now just to emphasize the wonkiness here, when we are inside grouping symbols. This one too, it's twice as tall. This one half as tall. But when it comes to the width, it's the reciprocal. So it's going to end up being the reciprocal of 2 is 1/2. So it'll be half as wide, and this one, the reciprocal of 1/2 is 2, so it will be twice as wide. Let's look at that really specifically here. Okay, here's a point on the original y = x². Notice it's a distance of 1 from the x-axis. If I double that, it's going to come up here to 2. Here's a point on my original parabola. It's a distance of 4 from the x-axis. If I double it, it's going to now be up here at 8. So all the points are twice as far away from the x-axis. This point here is a height of 0 away from the x-axis. If I multiply that by 2, it's not going to change it. Okay, half as tall. So this one here, if I have a point at this location, and that's a distance of 1 away from the x-axis, half the distance, we'll put that at a half. This point on my original parabola y = x² is a distance of 4 away from the x-axis. Half of that is 2. So the point on my new graph is up here at 2. Okay, now let's look at affecting the width. If we're inside of grouping symbols, the reciprocal of 2 is 1/2, so it's half as wide. My original graph, this point right here, is 1 away from my y-axis, and half of 1 is 1/2, so it's now at half. This point right here is 2 away from the x-axis, and half of 2 is 1, so the point is now 1 away from the y-axis. Okay, this one here, 1/2, the reciprocal is 2, so it's twice as wide. It is a horizontal stretch by a factor of 2. Okay, so this point right here is originally a distance of 1 away from the y-axis. If I double that, the point is now 2 away. This point right here is a distance of 2 away from the y-axis, so let's double that. It's now 4 away from the y-axis. If you have addition or subtraction, it's moving the graph right, left, up, down. If you are adding or subtracting outside of grouping symbols, again, outside is affecting the vertical distance. And so adding, it's intuitive. If I grab my function here and I drag it up to, this brown one is my new graph. In this one, -2, it's going to grab it and drag it down to, once again, inside of grouping symbols, a little counterintuitive. It's moving it right and left, but addition is going to grab it and drag it left. So I grab my parabola, drag it left, and here we have it. Okay, this one here, my original y equals x squared, -2 grabs it and drags it right. Notice every point, here's a point on the original, drag it right to, there it is. Let's go ahead and put all of this together to graph this function. Keep in mind when you have more than one transformation, the order that you go is going to matter. I like to do my stretches and compressions first, followed by reflections and then movements. To help you remember that, you wake up in the morning and you stretch. Then, before you walk out the door, you check your reflection, any toothpaste there. All right, and then move about your day, right, left, up, down. Looking for stretches and compressions, I'm going to look for multiplication. So looking for multiplication, I see this ×4 here. The 4 is outside of grouping symbols, so it's going to end up being 4 times as tall. Looking at that, here's my original parabola right there, parent function y equals x squared. This point is 1 away from the x-axis. Multiplying a height of 1 by 4, I get 4. So this point is now up here at a height of 4. So my parabola, my blue parabola, I've had a vertical stretch by a factor of 4. Next thing I'm going to look for is any reflection. So looking for the negative, and I see a negative right here. That negative is outside of grouping symbols. So we're going to reflect across the x-axis. So taking the blue one and flipping that across the x-axis, I end up with this green one. And then finally, move about my day. I'm going to look for right, left, up, down. Inside grouping symbols, so it's affecting our horizontal, and it's a little wonky. It's the opposite of what we think. So -1 is right 1. And then outside of grouping symbols affects up and down. World makes sense. So adding 3 is moving it up 3. So grabbing this green one and dragging it right 1 up 3, I end up with this brown one. It doesn't matter if I did up 3 then right 1, that's fine too. And just a little side note, if you did change the order of number 1 and 2, you'll still get the same graph, but you've got to save those movements for the end. Let's look at finally the most challenging one of them all, is if you see a negative inside of grouping symbols and there's some other things going on in there, the very first thing you need to do is factor out that negative. So right here, notice I have this negative inside of grouping symbols, and when the negative is inside of grouping symbols, it is going to reflect across the y-axis, but I need to factor out the negative. Now careful, I don't mean outside of parentheses, you can't do that with an exponent. So if I factor a negative out of these two, I have a negative and then x plus 4, negative x minus 4. Okay, again, I cannot take that negative all the way outside because of the squared. Okay, so now that we have it written like this, let's go through our order, stretches and compressions. So we're looking for any kind of multiplication. We have a multiply by 2 outside of grouping symbols, so it's going to be twice as tall. Here's my original graph here. Let me actually just move, this one over to help us. Okay, there we go. All right, so if I am twice as tall, my original function here, x squared, it's distance of 1 away from the x-axis. If I double it, it's now up here at a height of 2. This point, for example, is 4 away from the x-axis, so if we double that, it's up here at a height of 8. Okay, so we vertically stretched by a factor of 2. Then next, we're going to look for any kind of reflections. And so the reflection for this one, it's going to be across the y-axis. And so if I reflect this green one across the y-axis, this point mirrored across is still there. This point mirrored across is here. This point mirrored across is here. It's not going to look any different after I finish mirroring this across the y-axis. And then finally, I have the +4 minus 3 inside grouping symbols, right and left, and it's a little wonky, so the add 4 is left 4, and the minus 3 outside of grouping symbols is down 3. So grabbing this green one and dragging it left 4, down 3, I have my final graph. A couple other small things to consider. Number one, when you're finished graphing, like transforming is just a shortcut for graphing it by picking a number, plugging in that number, getting an answer, and plotting a point. So at the very end, if you're doubting yourself whether or not you have shifted your graph around correctly, just pick a number, plug it into your equation, and see if it plots a point on your final graph. So for example, the vertex of my final graph is at -4, -3. So if I plug -4 into my original equation, I should get -3. So let's try it out. -4 is 4. 4 minus 4 is 0. 0 squared is 0. 0 multiplied by 2 is 0. And 0 minus 3 is -3. If you substitute -4, you get out -3, back 4, down 3. And that point is on my graph. So I'm feeling very confident that my final graph is correct. And then last silly way besides, stretch, then reflect, move about your day, is to remember when you're inside parentheses or square root or inside any kind of grouping symbols, when you're inside, you're going stir crazy. So if you're inside, it's going to be the opposite of what you think. If it's multiply by 2, it's half as wide. If it is adding 4, it's going to be left 4. All right.